Do you see? Do you see? This is triangle of Lemnisky. It is placed between superior cerebellar peduncle. Do you see? Between do you see? Between do you see inferior arm? Do you see? Of the colliculus. Do you see from medial geniculate body to the colliculus? And do you see? And here will be cerebral peduncle. You can see here will be triangle. Superior cerebellar peduncle, cerebral peduncle, do you see? And above will be inferior arm of the inferior colliculus. Da, I draw by, do you see, pencil. Do you see? Do you see? This is triangle of Lemnisky, inside of which is placed gray matter. I explained you the cochlear or hearing part of the vestibular cochlear nerve. Vestibular part. In the ampulse of the membranosus labyrinthis of the semicircular canals, in the uterus and in the sac, I will draw. Do you see? This will be uterus. Do you see? This will be sac. This will be ampulse of the semicircular canals. Are placed receptors. From receptors begin dendrites. Dendrites complete into the bundles. Dendrites complete into the bundles.
You zoomed it very little, made it little smaller.
I was zooming across the drawing.
Так, I don't see semicircular.
It's there now.
I don't see my semicircular canal. I don't see the February semicircular canal.
She has her own semicircle.
Madame Marina took and didn't. I find it. Look at here. Look at here. Do you see? This, do you see, is base of the cochlea. Do you see? And here exit cochlear nerve. Do you see? Cochlear nerve. This, do you see, will be the sac, membranosus inside. Here will be the uterus inside. Here will be ampulse of the semicircular canals, in which are placed receptors. From this, each region exits bundle. Do you see? And each bundle is formed by dendrites. Here we have exit, do you see, of the cochlear nerve, which is formed by axons. And here we have exit of the vestibular nerve, which is formed by dendrites. The dendrites, they enter into the vestibular, into the internal acoustic meatus, and here they have the ganglion, vestibular ganglion, in which are placed bipolar cells, to which came dendrites, from which will exit axons. Because biporus acousticus internus will exit vestibular cochlear nerve, which is formed by axons. Did you understand? The ganglion for location of the bodies of the hearing part will locate in the cochlea. The DVC bodies of the vestibular equilibrate part will locate inside in the internal acoustic meatus. And here will exit vestibular cochlear nerve. Vestibular cochlear nerve will come to the superior, inferior, medial, and lateral vestibular nuclei. Vestibular nuclei. From vestibular nuclei, will go to the thalamus, and from thalamus to the medial temporal gyrus for the concrete analysis. Thalamus is imposed, if you remember, it takes part in the primary emotions. For example, you do visit for your friend, and he lives on the 40th floor in the house. You come, do you see, to the window, you look, and you have abnormal emotions. And do you see, in 0 point some seconds, this information came to the cortex, and cortex corrects your emotions and informs you, go out from window. No, or some another, do you see? Thalamus for the primary emotions. And you can see, and the medial temporal gyres for the concrete, do you see, concrete analysis of your position. Do you see? Okay, my dear, cerebellum. Who remembers cerebellum? This for what function?
Coordination.
Coordination. But listen to me, cerebellum for the production of the coordination, do you see, he must know about position of hour. Because from vestibular nucleus to the cerebellum will go vestibular cerebellar vein. Here, do you see, into the cerebellum will enter vestibular cerebellar vein. Vestibular cerebellar vein. It will come into the cerebellum. Also, do you remember we do the spinal reflexes? Do you remember? We do the spinal reflexes, and also we have extrapyramidal veins which come to the spinal anterior horns. Do you see? And they, do you see, we produce some mobility, and this mobility is correct. Why? Because do you see, from vestibular nuclei to the anterior horns of the spinal cord will direct vestibular spinal vein. We described it. Here will be vestibular spinal vein. Do you see? Which does correction of the our mobility. Do you see? Vestibular spinal vein. Another. Do you see? This is medial brain. It's do you see roof, which is called lamina tecta, which is formed by superior and inferior colliculuses. And we studied in the superior colliculuses aplacid vision, subcortical centers, and inferior colliculuses aplacid hearing subcortical centers. But in this plate, in the center, is placed the some another nucleus. Here, there is in this plate, is placed nucleus of the intermedial median bundle. Intermedial medial bundle. Median bundle. The word median informs us about what? It is lone, because median can be only lone. You can see. From this, it is called two scientists describe this nucleus and this bundle, Clark and Stillinger bundle. And from it goes below, do you see, this, do you see, bundle, which is from this nucleus, goes below the bundle. And this bundle has a very interesting situation. This bundle connects with oculomotor nuclei, with, do you see, abducens nucleus. But abducens nucleus will be opposite, do you see, collection. And with, do you see, ambiguous nucleus, and with dorsal nucleus of the vagus nerve, and with solitarius nucleus. With nuclei of the glossopharyngeal nerve, of the vagus nerve, with nuclei of the nerves which rotate the eyeball in the orbit. These nerves, they control the muscles which rotate eyeball in the orbit. Do you see? It is called longitudinal median, longitudinal intermedial bundle. Did you listen? Longitudinal intermedial median bundle. What it does? Listen to me. If I want to look at ceiling, Sharu. If I want to look at ceiling, I do function by both eyes. If I want to look below, I will do function by both eyes. Did you understand? And you can see this, do you see, longitudinal bundle, it controls, do you see, the common, do you see, rotation of the eye in the orbit. Only, do you see, abducens nerve, do you see, from right portion of this bundle will go to the left, from left will go to the right. Because, do you see, when we'll do abduction by one eye, another eye doesn't do this abduction. You can see also if you will travel by train and through the window look at nature, and you can see how do you see the electric sticks, do you see fly, do you see how the trees fly, and if you will rotate your head to your friend, by some seconds your eyes, do you see, will fly. Why? Because, do you see, from this vestibular nuclei will be connection with this median, with this intermedial median nucleus of the intermedial median bundle. Listen to me. Why, if you will rotate your eye, do you see, to a friend, and your eyes will do you see, very fast mobility to sides. This is called horizontal nystagmus. Because vestibular nuclei, they know they don't change position by your body, and do you see, and they inform, do you see, medial bundle by your confuse, because do you see, can be this nystagmus. Do you see? Connection with nuclei of the glossopharyngeal and vagus nerve. Sometimes you travel by plane, by train, and sometimes, do you see, you have discomfort, do you see, and sometimes you have vomiting. If you know glossopharyngeal nerve, it controls the mucous membrane of the pharynx, larynx, do you see, palate, and do you see, discomfort will be by this sensory innervation. Vagus nerve, it controls the internal organs, and sometimes when you travel, for example, by plane, will be vomiting. Why? Again, do you see, this vestibular nuclei inform, do you see, the nucleus of the intermedial medial bundle, and when it goes, do you see, below, it informs about, it's confused, the dorsal nucleus of the vagus nerve, and it will do the vomiting. Did you understand? You can see this is vestibular cochlear nerve, equilibrate part, do you see, it is formed by vestibular cerebellar way, vestibular, do you see, thalamocortical way, vestibular spinal way, and the vestibular mesencephalic vein for the connection with Kark-Schilling nucleus. Did you understand? This is a whole vestibular cochlear nerve. Another glossopharyngeal nerve. Do you remember last time I drew you the scheme of the pyramid of the temporal bone, but I expand by scheme 3 each side by do you see, 1 plane. Do you remember? Today we will draw again this temporal bone, but if last time, do you see, was posterior, do you see, posterior and anterior inferior, now will be opposite. You can see, this is brain stem. This will be fourth ventricular cerebral aqueduct, pons, medulla oblongata. This will be lamina tectis cerebellum. In the dorsal side of the pons is placed solitarius nucleus, which continues from pons into the medulla oblongata, and which is common with intermediate part of the facial nerve. But now you will get another information with what another nerve it is common. Glossopharyngeal, vagus, and accessory nerve, they developed from same embryonal germ. And because they have the same nuclei, they exit from brain behind of the olive bilateral groove, and they exit from skull by jugular opening. Because they have the same nuclei, they have common exit from brain and common exit from skull. Did you understand? You can see, this is solitarius nucleus, it will be common for the intermedial part of the facial nerve, and it will be common for the vagus nerve later. You can see, another will be ambiguous motor nucleus, like twins nucleus, do you see, ambiguous. And another nucleus will be salivator superior nucleus. Salivator inferior nucleus, excuse me. Salivator superior for the facial, or salivator inferior nucleus. Look please here. Here will be
Salivator is vegetative, right?
salivator is vegetated, agree. You can see. This will be, do you see? There, do you see? Anterior side. Last time we started by, do you remember, posterior side where was the internal acoustic meatus. This will be anterior side over the pyramid. This will be anterior side, this will be posterior side, and this will be lower side, near the which will be jugular opening. Do you see? Here will be, do you see? Here will be inferior part, do you see? Here will be jugular opening. And this will be lower side of the pyramid, do you see? You can see the following. Here will be orbit, superior orbital fissure. This will be lacrimal gland. For understanding this is orbit, I will draw your eye. Here will be, do you see? Here will be pterygopalatine fossa. This will be maxilla vestis. And this will be pterygoid process. We draw by last time. Do you remember? Here will be foramen ovale. Here will be foramen rotundum. Here will be ear, and here will be parotid gland. Here will be the tongue. Here will be the tongue. Here will be carotid common artery, which divides into the carotid internal and carotid external. Here will be endocrine tissue, which is so analogous of the medullary part of the suprarenal gland. But it is called carotid glomerulus, carotid stagio, carotid glomerulus. This will be the soft palate, you can see. And here will be soft palate, here will be larynx, aperture of the larynx, thyroid cartilage, trachea. And here will be pharynx, which continues into the esophagus. Here will be palatine tonsil. Here will be cerebral falx, tinctorium cerebellum, and here will be, ear I draw you. Ear I draw you. This will be ear. My dear, glossopharyngeal nerve. It is mixed. It has motor portion. It is very, very smaller. From motor portion, by jugular opening exits and comes to the wall of the pharynx, do you see, is only one motor portion. It controls only one stylopharyngeal muscle. Do you remember pharynx, muscular sheet of the pharynx? It is formed by skeletal muscles. Three of them complete into the superior medial and inferior constrictor, and two from them will be palatopharyngeal, and stylopharyngeal will complete into the posterior wall. Palatopharyngeal, they will complete into the lateral wall. Stylopharyngeal is controlled only by glossopharyngeal nerve from ambiguous muscle. Did you understand? Another vegetative portion. Listen to me. Here is jugular fossa, and in front of is carotid canal. On the border between jugular fossa and carotid canal is placed very smaller depression, with smaller opening. Here do you see begins tympanic canal. And this place is called Petros Fasud. Petros Fasud. You can see, this is, do you see, here will be Petros Fasud. And here do you see, will come, do you see, by Petros Fasud into the tympanic cavity, this is tympanic cavity, will come, excuse me, will come, do you see, the vegetative, excuse me, will come vegetative portion, and it is called tympanic nerve. Tympanic nerve. Tympanic nerve, when it passes through the tympanic cavity, and tympanic cavity is covered by mucous membrane. Here, do you see, will begin to the mucous glands the branches of the vegetative branches. But do you remember, they cannot go directly to the glands, because here will be at first microganglions for the decreasing of the impulse, and after microganglions, postganglionial fibers will go to the mucous glands, which are placed in the mucous membrane. In the mucous membrane will be microganglions and the glands also, those mucous glands. But this tympanic nerve gives these branches for the control of the mucous glands, and will exit from tympanic cavity by lesser the hiatus of the lesser petrosus nerve, and will get name lesser petrosus nerve. Lesser petrosus nerve. Listen to me. It will come, do you see, to the oval opening. And do you remember, through the oval opening, we have direction of the trigeminal nerve. Do you remember? Mandible branch of the trigeminal nerve. Mandible branch of the trigeminal nerve gives auriculotemporal branch. Auriculotemporal branch.
Sensory right now.
Huh?
Sensory.
No, this is trigeminal nerve, sensory, auriculotemporal branch. The mandible branch of the trigeminal nerve, it is mixed. Now we speak only about its sensory portion. And here, on this will be, do you see, third branch of the fifth nerve. Do you see? And do you see, on this branch is placed otic ganglion. To the otic ganglion, by mandible branch, through the oval opening, do you see, will come lesser petrosus nerve. Do you see, it will do multiplication. It will do multiplication. And after multiplication by auriculotemporal branch will come to the secretion tissue. It will come to the secretion tissue of the parotid gland. Did you understand? Здравствуйте. Ну, заходи. Ну, говори.